Welcome students, Algebra 1 to Greatest Common Factor video. We're going to have 80s music in our background today, starting with 99 Red Balloons, one of my favorite 80s songs of all time. So Greatest Common Factor, just a couple of examples here. We're looking at finding the factors of each number and finding the biggest one that's common. Factors of each number and the biggest one that's common. All right, there's another way to do it, and we will take a look, but let's jump right in with definitions. All right, factors. Factors are what you multiply. They're what you can multiply to get a number. So factors, for example, of the number, let's do one that has a lot of factors. 24. Factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. So those are all the factors. They multiply to give you that 24. Multiples, on the other hand, multiples are what you get after multiplying a number by an integer. So multiples of 24 would start with 24, and then 48, and then 72, and then 96. So the list of multiples is infinite. There's an infinite number of multiples. My infinity symbol's a little uneven. There we go. But the list of factors is finite. Factors finite, multiples infinite. So your list of factors ends. Your list of multiples can go on forever. Just keep multiplying that original number by a bigger integer. Now, when we talk about greatest common factor of a set of monomials, is the largest monomial that is a factor of each term in the set. Let's do an example. Well, before we do an example, let's talk about how we're going to actually find the greatest common factor of a polynomial. We're going to start off by prime factorizing each of the terms in an expression. Then we're going to find the factors common to each term. Then we're going to find the product of the common factors. That's the greatest common factor. Let's do a couple of numerical examples first. Let's do 56 and 14. So when we say prime factorize each term, we're going to prime factorize these numbers. 56 is 8 times 7. 8 is 2 times 2 times 2. And knowing that makes it a little faster for you to prime factorize. So 56 is 2 times 2 times 2 times 7. And 14 is 2 times 7. Your common factors here are 2 and 7. And we're going to multiply them together. And your greatest common factor is 14. Now remember, a number, can be a factor of itself. So 14 is a factor of 14, and it's also a factor of 56. So sometimes you'll be looking at a situation where one of the two numbers is the greatest common factor. Let's do another pair. Let's do another example. I'll draw a line down here. How about 36 and 28? Take a second and prime factorize them. Okay, 36 is 6 times 6, and 6 is 2 times 3. So 36 is 2 times 2 times 3 times 3. That way you have 2 times 2, 4. So 2 times 2 is 4, times 3 is 12, times 3 is 36. How about 28? 28 is 4 times 7. 4 is 2 times 2, and then you have times 7. Common factors are 2 and 2. Oh, I forgot to switch colors. So that means we're looking at 2 times 2 for our GCF, 4. So to summarize real quick, before we do some with actual polynomials, you can either just find the factors and then find the biggest one that's in common, or you can prime factorize it down, which is what I did here. Find the ones in common, multiply them back together. You are going to do most of this part mentally over time. If you're not ready to do it mentally now, then go ahead and put it on paper for the moment. All right. Before we start actually doing some examples of polynomials, let's talk divisibility rules. So your basic divisibility rules, some of them I know you know by heart. 2 if it's even. So if it ends in 0, 2, 4, 6, or 8. If it's even, it's divisible by 2. For the number 3, to find divisibility by 3, add the digits. If the sum of the digits is divisible by 3, then the original number is divisible by 3. So for example, 111, the number 111, definitely divisible by 3. How about the number 4? The number is divisible by 4 if the last 2 digits form a multiple of 4. Another thing you can do is with prime factorizing, if you can see two twos in the number when you prime factorize it out, let's do like 54. Okay? If there's 2 2s in there, then it's divisible by 4. 54 is going to be, let's see, 27 times 2. So it's 2 times 3 times 3 times 3. See, there's only 1 2 there. Only 1 2. 54 is not divisible by 2. But let's look at 56. 56 is 2 times 2 times 2 times 7. 2 2s. 56 is divisible by 4. So yes, it is. 5, of course, ends in a 5 or a 0 to be divisible by 5. To be divisible by 6, it's got to follow the rules for 2 and 3 at the same time. There's no simple divisibility test for 7s, unfortunately. I will show you a cool divisibility trick for 7s that we might use in math counts, but it's not really a hard and fast rule you can use comfortably. For 8, again, there isn't a very good rule. It's if the last 3 digits form a multiple of 8, and that's not something you're always going to be able to recognize. The rule for 9 is just like the rule for 3. You're going to add the digits. If the digits form a multiple of 9, then you've got a multiple of 9, the original number. And of course, for 10, it's got to end in a 0. Now, this doesn't take into account variables. We'll look at that on the next slide. But it does take into account the numerical part of things. So let's get started. All right. And again, I keep saying that, so I must be forgetting what the next slide is before I move to it. But what is factoring? Well, that's what we're about to do. Factoring is the process of finding the factors. Prime factorize a composite integer by breaking it down into its prime factors. We already saw that on the previous slide. When we factor a polynomial that has a GCF, we're dividing that GCF from every term. This is what we're about to do. The factored form is written as a product of a monomial, that's the GCF, and a polynomial in parentheses. So it's sort of like Jeopardy math. It's kind of like we're playing Jeopardy math, because what we're doing is we're kind of giving the original problem. So let's try some. And finally, we get to the examples. All right. Start by finding me the greatest common factor of these two. Now again, we're going to be doing a lot of this mentally over time, but for right now, let's write it out so we know what we're doing. 15z is 3 times 5 times z. 35 is 5 times 7. Okay, those are dots. They're just kind of messy. Excuse my mess. Common factor, there's only one. It's 5. So we're going to factor out that 5. So we leave the 5 out front. And what we're doing is we're saying, all right, what's 15z, right here, 15z divided by 5. 15z divided by 5 leaves me 3z. And that's what goes here. Oh, cross my z. All right, 35, divide off the 5. So minus 35 divided by 5 would leave me a minus 7. And we have factored that polynomial. And that's your answer. So you're going to do the same thing all the way down. So start with finding your greatest common factor. So what's the greatest common factor of 8 and 4? So start with the 4. Does the 4 go into the 8? Yes, it does. So 4 goes into itself and it goes into 8. That is going to be the numerical greatest common factor. Now look at the terms. Look at the variables. What's the smallest power of y that the two terms have in common? The smallest power of y the two terms have in common is y to the first. So we are going to factor out a 4y from this polynomial. So it's 8 divided by 4, and what does that leave me? 2. And then it's y cubed, divide off one of the y's, the exponent ticks down by 1. 4y divided by 4y would be 1. So in the parentheses for that one, we have 2y squared plus 1. Now let's double back a bit and let's think about how we can check our answers. How can I check my answers here? What I can do is, in my mind, mentally, I can go ahead and do the distributive property and make sure that this original problem is what I get when I multiply that out. 5 times 3, 15. 5 times 3z, 15z. We're good for the first term. 5 times minus 7, minus 35. This, by the way, is my all-time favorite 80s song. It's called Take On Me by a-ha. Just so that you know, I was only 1 year of age in 1980, so I didn't really live through the 80s, but I had much older sisters, so all the music kind of stuck for me. Anyway, moving on with the polynomials. So obviously this has gotten more complicated here. Start by looking at the numbers. 9, 15, and 12. Greatest common factor of 9, 15, and 12. And again, let's write it out for now because we probably should just go ahead and do that to be comfortable. 9 is 3 times 3. 15 is 3 times 5. And 12 is 2 times 2 times 3, because it's 4 times 3, and 4 breaks down to 2 times 2. The only one they have in common all the way through is a 3. So we are factoring out a 3. What about the smallest exponent, smallest power of x? Well, you have here a 2, a 4, and a 6. So the smallest one they have in common is a 2. Factor out a 3x squared. All right, and now I'm going to have to erase all this mess because it's in my way. Oh, it won't let me. Oh, well, that's okay. All right, so now what we're basically doing is dividing off the 3x squared from each one. So here's another way for me to think about this. I can write it each time. It still sits out front right here, but let's do the division for each one. So 9 over 3 would give me 3, x to the 6th over x squared, x to the 4th. So 3x to the 4th power. 3x to the 4th power, sorry. Okay. Minus, I'm going to have to sort of veer downward, like that. All right, minus. Now, 15 divided by 3 is 5. So it's minus a 5. X to the 4th over x squared is x squared. Last one, 12x squared over 3x squared. 12 over 3 is 4, so it's plus 4. And x squared over x squared will cancel out. And there's my answer for that one. Sorry for the mess. Last one. Now, they're all negative. When we prime factorize a negative, we are always going to divide out a -1 first. So, I'm going to get a negative. They're all divisible by 3, but not by 6. They're divisible by 3, but not by 6. Whoops, sorry about that. Hit a tool with my hand by accident. Smallest exponent, smallest power of a they have in common is just a to the 1st. So, take a second and divide that out and write what you have left inside the parentheses. What did you get? Hopefully you got 2a to the 4th plus, notice we're factoring out a negative, so this is a plus, 7a squared plus 18 over 3, 6a over a cancels. And again, we're done. Let's double check by multiplying it out mentally. -3 times 2, -6. a times a to the 4th, a to the 5th. Check. -3 times 7, -21. a times a squared, a cubed. Check. -3 times 6, -18. a times no a at all, a. So we have factored those 4 polynomials. We're going to continue on with the next video, and it's going to be taking a trinomial and finding the binomial factors. If you follow the procedures that we give you and you practice with the math in class and outside of class, it's not going to be hard at all. See you guys in class. Hope you enjoyed the greatest common factor video with your 80s background music.